to this.
Okay, we out here.
Look at this math. We out
fun.
here, 6'9", you know, real.
Alright, we're finding the second derivative of secant x. So we start with y equals secant x. And we define it by 1 over cosine x. And first we have to find the first derivative of secant x. So we're going to use the quotient rule here, which is shown. And so we're going to do 0 times cosine x minus 1 times negative sine x over cosine x squared using the quotient rule. That equals sine x over cosine squared of x, which is really just 1 over cosine x times sine x over cosine x if you rewrote it. And so therefore we get the derivative secant x over tangent x. So the next step, we have to find the derivative of that. Well, we already know what the derivative of secant x is since we just found it. Now we have to find the derivative of tangent x. So over here, tangent x can be described as sine x over cosine x. And using the same quotient rule that we used in the problem before, again, that's the quotient rule, we get cosine x times cosine x minus sine x times sine x all over cosine squared x.
And that simplifies down to cosine squared plus sine squared x over cosine squared x.
Simplifies down to that, which is really just
1 over cosine
when cosine x is added to sine x, it's 1.
You can cancel.
It's a nice little property there. So now we have 1 over cosine squared x, which is actually secant squared x.
There we go.
So now we have secant x times tan x as the derivative of secant x, and the derivative of tan x is secant squared x. So we're going to use the product rule here and set it up real nice to get secant x times tan x plus secant squared x times secant x. Simplifies down to secant x times tan squared x plus secant cubed x, which is our final answer of secant x times tan squared x plus secant cubed of x. Patrick?
Wonderful, I love it. Everything about it. Kai Wolf.
Shout out to Clemens.
Shout out to Clemens.